paper, plastic, paper, plastic, paper, plastic, paper. Plastic is much better. And look at plastic bottle recycling. Yeah, so after you put these bottles in the plastic bins around school, they then get transported either by train or by very, very, very large trucks to a recycling facility. Oh, hey, look, a use of recycling. Ah, genius. Alright, so once these are taken to the places where they're going to be broken down, they get sorted. Now they get sorted by these numbers. Now it goes from numbers 1 through 7. And with each number, they each have their own chemical makeup, in which they're composed of, well, Patrick will talk about all that.
4.
Number 4, excuse me. The other ninja, number 4, will be talking about that, in which he'll explain the chemical equation and how they all each have different densities. Now, what is a chemical equation?
A chemical equation is made up of chemical symbols to represent a chemical reaction.
And they each have their own density. Each 1, 2, 3, 4, 5, 6, 7, they each have their own density.
The density of a substance is found by taking its mass divided by its volume. A polymer is either a natural or synthetic molecular molecule made up of multiple repeating units called monomers.
Number 1 plastic is known as polyethylene terephthalate, which you could also call PET or PET. Most disposable soda and water bottles are made of number 1 plastic, like this Wendy's cup here, and it's usually mostly always clear. The formula for polyethylene terephthalate is C10H8O4. Kind of at the center is we have 6 carbons with hydrogens on them. Then another carbon off to the side with an oxygen here. All the reds are oxygens, blacks are carbons, yellows are hydrogens. Right here is where it connects onto the next one. The other half starts off with a little carbon and oxygen on both sides, which connects to carbon here, 2 hydrogens, another oxygen to connect to the next molecule. It's pretty safe normally to eat and drink out of. You know, we've gone to Wendy's and McDonald's multiple times and have not died yet. But it kind of has a porous surface with lots of holes in it that bacteria and flavor can accumulate. After a while, it gets a little unsafe. Number 2 is high density polyethylene. Just plain old polyethylene. The last one had another word on it. Somehow they came up with calling this polyethylene carbons with hydrogens on them. It can be really long, as long as up to 20,000 carbons. I really would have wanted to make one of these, but Mr. Erickson only has a limited amount of these model atoms. It makes things like milk jugs. There's all kinds of other food containers. Personally, this is my favorite of all the plastics, because first of all, 2 is an even number. No risk of holes coming into the plastic, unlike our number 1 plastic over here, the polyethylene terephthalate. Speaking of which, you may have noticed that this is high density polyethylene, and this is polyethylene terephthalate. So what in the world's up with that? Well, if you notice, here's polyethylene terephthalate. There's a part on this first one that's very similar to all of the second one. See where there's the blacks, which is the carbons and the hydrogens. They go together. So this is the polyethylene part, and this is the terephthalate part.